So you just have like a before and after.
How do you turn this?
Oh, that would help. What are towers?
I know. Look at the TVs.
Oh shit.
Isn't that cool?
Can we rent this room for reasons?
So
Financial reasons?
Microsoft sell. Oh, that joke fell off.
I mean, I was gonna say LAN parties, but
Oh.
okay. So if all you guys are in the same group, we're gonna get somebody to give up a computer so these guys can have a computer as well. I don't know how computers work. You guys knock yourselves out.
Yeah, here. Oh.
As long as one person from each writing group can do this.
I got it.
Nobody. All right then.
I'm not. It doesn't say anywhere that I am. Please read the column. Perfect.
What is this? Just like Excel? So it's Excel.
Student email. Where's Minitab?
You don't have to put in the
Oh, well, that's English.
Excel makes things look pretty for the business world, but it's not good enough for people in science. In fact, it's not great.
Excel is kind of not that amazing.
It's not. You should not imagine.
The only reason I would ever use Excel is to do strings of calculations.
When your children's reading.
Presentation,
Like tables.
just gonna listen in and just see what someone all these.
No, why did you?
You could leave your shirt.
Probably could, but I look forward to being entertained.
You're on the spot now, yeah?
Not on this spot.
No pressure.
Motivated, inspired. Inspired to get keep in a room right now.
Alright, so everybody's on their computers, logged in?
Not yet? Oh, it's still booting? Sounds like my computer. Hence the problem is, I think I had to boot it.
So what we want to do today is enter your data into Minitab. Use the software to do a statistical analysis of your data. For example, you guys might measure heart rate, and in your resting group, if that's what you have, it might be 70. In your treatment group, it might go up to 90, but even though it's mathematically higher, it may not be statistically higher, and so therefore we can't say that exercise has increased heart rate. And so it's important that we make that distinction, and so that's what we'll do today. So we'll enter our data and run some stats, and then we're going to represent our data graphically. And so through the combination of the two, we can get a really good picture as the reader of your paper as to what happened in your study. The stats is fairly straightforward. The graphing, in order to get it in a certain type of format that is appropriate for journal articles, it takes a bit of work. So you guys may want to take notes on exactly what we do to modify the graphs, just so they're properly formatted. But with Minitab, it's all very simple and very straightforward. And once you do it a couple of times, you'll never forget again. The program's really, really intuitive, and so it makes everything really easy. So just to start off, I'm going to make up a data set for heart rate. And Minitab works very similarly to how Excel does. So at the top of one of the columns here, I'm just going to write rest HR for resting heart rate. And then I'll write, let's say you ran up and down stairs, we'll say stairs heart rate. Okay? So what you guys can do is actually enter all of your data in here at once. And you can pick and choose which data you want to graph and which data you want to run stats on fairly easily. And That way you've got all your data in one place. And we can do certain things with it.
I just see you do that's clearly damned.
What?
Almost all this damn.
Oh.
So we have our data set. Okay? When you guys are writing your results, it's important that you write your numbers appropriately. And so the way we do that in physiology and in life sciences is by listing the means plus or minus the standard error. And depending on which statistics you use, those pieces of information will be given to you, and sometimes they're not. So what I'll do is show you guys a really easy way for you to get all of your means and standard errors for all of your data. So for example, if you guys had your entire data set here, and you wanted to know something about those numbers, what you can do is go stat, basic stats, and then into descriptive statistics. Okay, so we're gonna display descriptive statistics. And Minitab is a really easy program. Essentially, you just wanna double click the thing that you wanna do. So in this variables box, we wanna put our variables. So now we can just put in our two heart rates. And then if we click the statistics box, we can decide which of these values we want to see. So for you guys, N probably isn't important, min and max probably isn't important, the quartiles aren't important, and standard deviation isn't important. So to make it easy on you guys, let's just display the mean and standard error of the mean. Hit OK, and hit OK. And so for all the variables that you've selected, we now have a mean plus or minus our standard error. Right, so it's an easy way for you guys to see these numbers, and it's gonna make writing your results section a lot easier. Okay? So if you guys had a whole bunch of your dependent variables here, then you would easily be able to get the information just by selecting them. So next what we'll do is run statistics. So I'm presuming for all of you guys, we measured a person at time 1 and measured the same person at time 2. And that's how everybody's gonna be doing it or has done it? Okay. So the statistic that we want to use for that is called a paired t-test. And what it does is it compares the groups in a way that implies that each value is tied. And so what that means is that these two values here belong to the same subject at two different time points. And so that makes it a tied value or a paired value. And so if we think about this, the difference between these groups, if nothing changes, should be 0, right? So if we subtract each of these columns from, or each of these rows, if there's no difference between these groups, then the answer is 0. And what we want to do is see if the difference is statistically different than 0 or not. And so we can really easily do that with a paired t-test. And so in order to do that, we're just going to go into the stat tab, into basic statistics, and then just down to paired t-test. Okay? And for you guys, I think you have a drop-down box here. So if you just select that your data is represented in separate columns, and then you can just double-click on the data. If you can't see the data in the column, you'll just need to click into a box, and then the data should pop up. Okay? So we enter our two data sets into the two samples that we want to compare. So in this case, it's resting heart rate and exercise heart rate. Everybody's okay with that? Okay. And then we just hit OK. And so Minitab gives us this output. And so in this case, Minitab is giving us our mean, a standard deviation, and a standard error of the mean. So like I said, we'll use mean plus or minus the standard error. And then it also gives the difference here because really what we're looking at is to see if the difference is statistically different than zero. Okay? The most important thing here is going to be our p-value. Okay? And so this is a very important message that you guys really have to understand before we move any further. Okay? If you have a p-value that is less than 0.05, then it means the two groups that we're comparing here, in this case the resting heart rate and the stairs heart rate, are significantly different from each other. Okay? So when we look at the means here, the resting mean heart rate is lower than the one for the stairs, and so we can say that the treatment of running up and down the stairs has caused a significant increase in heart rate. Okay? So everybody's on board with that? If you run your statistics and you have a p-value here that is greater than 0.05, then we cannot consider our groups to be significantly different. Okay? So hypothetically, my p-value here is 0.1. Okay, so it's greater than 0.05, even though the heart rate is, quite a bit higher. Mathematically, it's not statistically higher, and so therefore we can't consider it to be actually higher. Does that make sense to everybody?
Dan, are you explaining to them that they shouldn't write 0.000, it should be 0.0?
So remember, p-values of less than 0.05 indicates that the groups you're comparing have significant difference. And if the p-value is greater than 0.05, then the groups are not different.
What's the difference between being like mathematically different and statistically different?
So mathematically, they're just numbers. They're higher or lower.
Okay.
So you look at the two numbers, and we know that 106 is higher than 65. So mathematically, it's higher.
Yeah.
Okay. But statistically, it's not if your p-value is greater than 0.05. So I'll just give you guys an example here.
And that's the only time you really are supposed to use the word significantly in some kind of written text, is
Okay.
if you're talking and referring to the fact that you use statistical testing. Okay, if I see significantly and it's not backed up, I will cross it out because it's meaningless to me. It's just a mathematical trend you observe, but the word significantly implies you used a test that tells you that the numbers are significantly different.
Okay, so what I've done here is I've changed my data set a little bit. So I'm gonna run the same paired t-test. Okay, and now you can see mathematically the heart rate for the stairs is still higher than the resting heart rate, but my p-value is quite a bit above 0.05. So even though the numbers are different, we can't consider the groups to be statistically different. And so we would say here that exercise by running up and down the stairs has not changed our heart rate. Okay? Does that make sense to everybody?
You've been awesome.
Now, as Anna pointed out, if you guys are having really strong effects, so if you have a very low initial heart rate and a very high post-exercise heart rate, you might get a p-value that reads as 0 here. Now, Minitab for the paired t-test reports to 3 decimal places, but we don't know that it's 0 to infinity. So we can't say p equals 0, because that really means that there's an absolutely impossible chance that the effect we're measuring is due to random chance, and we just cannot say that. And so when you guys get a p-value, what we do is we write it as p is less than 0.001. So we know that it's not exactly 0, but it's quite a bit less than 0.05.
So we can
Okay.
do that.
Does anybody have questions on that? So p-value less than 0.05, the groups are different. If it's higher than 0.05, they're not different. And p-values that are written as just 0 are going to be p is less than 0.01. Okay, everybody's okay with that? And so for you guys that are doing a before and after, what you can do is have all of your data entered here and just run paired t-test after paired t-test, and you'll get this little window. And so what you can do is see what you've done here is paired t-test for resting heart rate and stare heart rate. And so what you can do is scroll through your list, and you now have a list of all the statistics in one place for all of your dependent variables. So that can be extremely useful. And in the case of the paired t-test, it's also going to display the mean plus or minus the standard error. Okay? So now what we want to do is represent our data graphically. And so with Minitab, it's really, really easy to do. And so we'll show you guys how to do that. So we'll take our data set and we're going to graph it in what Minitab calls an interval plot. So what we're going to do is convert this into a bar chart. Okay, so we'll go interval plot. And we want to think about what we're doing with our data, right? We don't have just a single bar, but we're not grouping our bars together. We only have two bars that we want to compare, and so the multiple y simple interval plot is our best option. Okay? So we just hit OK, and in the exact same way that we've added before, we're just going to do that. Okay? Now, before you guys hit OK, this is the graph that you're going to get. This is an interval plot. Okay? It gives our data meaning, but it's not in the format that we would typically see. And so what we want to do is convert that into a bar chart. And so we can easily do that by going into the data view box here. And we want to check off bar, and we're going to uncheck the mean symbol. Okay? And we just hit OK, OK. And so we get this nice bar chart. Everybody's okay with that? And so you can graph all of your data this way. Now, if you guys have been looking into the literature at all, and you see the figures, you'll notice that the figures don't actually have titles. They have a figure legend that's written below the figure. So it'll say something like figure 1, comparison of whatever. And so for that reason, we're going to delete the title. Minitab's really easy. We just click on the thing we want to change and we hit delete. Okay? These bars now are showing the 95% confidence interval of our mean. What we want to use is standard error, and so we're going to change those bars. So the thing we want to change is the bars, so we're just going to double click on them. And we're going to go over to options and change that to standard error. And we're just going to leave it as a multiple of 1 standard error. Now you see on the graph here, we've got a two-sided bar, it goes up and down. It's okay to leave it that way, but typically in published works, you'll see just an upper one-sided bar. And so we get something that looks like this. So everybody's okay with that? Okay. And we can see now that its bars are 1 standard error. We can also delete that. So let's get that out of there. Okay. Now we need to make sure our axes labels are accurate and appropriate, and data doesn't really mean anything to us. So what we want to do is change it to what our dependent measure is. And so in this case, it's heart rate. So we just double click on the thing we want to change. We can affect the font. We can bold it, change the color if you guys want. And we'll just change it to heart rate. And don't forget your units. Okay? If you guys are missing units, you will be docked marks. And then we can also change our bottom one, because your bars are going to be labeled as to whatever you've got them listed in Minitab here. Okay? And you can't have the same label twice. So for example, if I knew that was heart rate and I said rest, if I wanted to say tidal volume, I can't do that. So we have to label them all according to their own specific labels. Okay? And so we probably want to change these labels just to make them a little more appropriate. And so again, we can double click, so we'll know that it's good when you have a top and bottom axis with the boxes here. So we're just gonna double click it. And we go over to labels. We're gonna specify our labels. With Minitab, anything that's contained within quote marks, Minitab considers them as one label. When you put a space in between words, it considers them separate labels. And so what we do is if we need a space in between our words, we put them all in quotation marks. So it tells Minitab that they're all one right there. Okay? So in this case, I think resting, maybe exercise, or something like that. You guys will have your own specific labels. But so now we have appropriately labeled boxes. Okay? Everybody's okay with that? Now if I were to paste this box into Word,
Yeah.
you know, it looks good, but there's some formatting issues that you typically won't see in journals. And so bordering is definitely one of those, so we need to affect that. So the first thing we're gonna do is change the outside border, and so we have the square on the outside, so we know that we've selected it. We're just gonna double click it. And we're gonna change our graph attributes. And so we want our fill pattern, which is the color here, to be none. Okay? But there's still a border around the outside of it, and we also want to get rid of that. So we can go into borders here and specify a custom border that is none. Everybody's okay with that? Okay. And so now, we have a better looking figure. But if you guys have been looking at the literature, you'll also notice that we don't have the top and sidebars, so we want to get rid of those as well. And we're gonna do that in a little bit of a different way than we did with the other one. So we're gonna select only the top and bottom axis, like this, and we're gonna double click on it again. Okay, and if you guys are changing your labels like we did before, you can actually just do this while you're doing that. And so we're gonna edit our scale, and we wanna show no high axis line. We wanna get rid of that. So when we're adjusting the top and bottom axes, we get rid of the high one, it's gonna get rid of our bar on the top. And we'll do the same thing to the side. Over to show, get rid of our high axis. Everybody's okay with that? Okay. So now when I paste this into Word, that's a figure that you would see in a paper. It's clear, the labels are all very clear, the boxes are there, we have error bars. And so this gives us a good picture of our data because it represents the mean as well as how much deviation from the mean each group has. Okay? Now, if you guys are printing in black and white, you might want to change what the bars look like, so we can be very clear that we're looking at two separate groups, okay?
Quick question.
Yep.
On mine, when I paste it into Word, it says individual standard deviations are used to calculate the intervals and like italicized writing underneath.
Okay, what you can do is actually just delete that in a
Okay.
similar way that we deleted the title and the information about the error bars.
Oh, yes, I see. Okay. Cool.
Okay? And so, sometimes we want to make our graphs stand out, so it's very apparent that we're looking at different groups, and this is especially the case when we're comparing multiple groups. And so if we want to change something, we can just double click it, and so make sure you have only one of the boxes selected, as opposed to both, like here, we'll select only one. And so if you're printing in black and white, color probably isn't the best way to represent your bars, and so what you can do is use a hatch or a cross pattern. Right? And so we get something that looks like this. Okay? Since you guys are going to be all submitting your papers electronically, color is probably a pretty good way to show the differences between the groups. And so if you want to do that, in the same way, we're just going to do a custom color, and we can select the color. Okay? And so this is a really good way to say, hey, we're looking at different stuff here. Okay? We don't want to use too crazy colors like hot pink, neon green. You know, colors that are easy on the eyes, but gives a really good representation. And something you want to consider is if you're doing colors, keep your resting group the same color for each of your bars, or for each of your figures. And so then I know, no matter what figure I'm looking at, if I'm looking at a blue box, in this case, it refers to your exercise treatment. Okay? Does that make sense to everybody? So we can just paste that directly into Word. Okay? Now sometimes you'll put it into Word and it'll get there and you're like, oh shit, I need to make a change. If Minitab is installed on the computer that you're using Word, what you can do is double click on your figure and it's gonna let you modify the figure like you can in Minitab. Okay, so that's a nice feature. Right, so you can change any of the functions just like we did in Minitab. Reads okay with that?
It's not scientific.
Okay. So, if you guys have been looking at the literature, you'll see below the figure, you have a figure legend. And so what we want in your figure legend is the figure ID number, so 1, 2, 7, whatever you guys choose, and a little description about the figure. Now ideally, in your figure legend, you guys are gonna give us enough information that we can read your figure legend and look at your figure and understand what you did to get that result and what the results are. So much so that we don't even have to read your paper to understand what happened. Okay? So for example, this one. I might say comparison of heart rate of students. And here would be a good time to maybe put in how many students were in each group. In this case, it was n equals 8. So a comparison of heart rate of students before and after maybe 60 seconds of exercise. So it tells me what you did to get the result, how many people did it, and what I'm looking at. Okay. Make sense, everybody? Now, one thing that I might suggest you guys add to your figures for data that has significant differences is an indication on the figure that there is a significant difference. And so what you can do is insert something, maybe a shape. Maybe we can do something like this. Okay. So now what we can add to our figure legend is arrows indicate significant difference between groups. And what we want to also add is that we consider p-value of less than 0.05 to be significant. Because in science, you can choose which p-value is significant. Some people use 0.01, 0.05, 0.1. For the life sciences, we generally use 0.05. And so we're saying that, hey, this exercise group is significantly higher than the resting group, and we know that because we've indicated with this. And we've said here that arrows indicate a significant difference between groups. Does that make sense, everybody? You'll often see a text box as well. And so what people will do is say, instead of doing a clip art, they'll do an asterisk. Okay? And you just might want to get rid of the border and stuff on that box, so you can format the shape and say no fill. Okay? So now we have an asterisk. Maybe we want to make it a little bit bigger. And then down here, you can just say asterisk indicates significant differences between groups. So now just by looking at your figure, I know that mathematically and statistically, there's a difference between your groups, right? So this gives me a really good picture of your data because it represents the means, the errors, and tells me that you have a significant change. Okay? I'll also give you guys an idea of just how you can maybe write a result for these data. Okay? So when you guys are writing your results section, you're going to have a paragraph or two with text that describe your results. And then on another page or at the very end of your report, you're going to have sheets that have your figures on. And so each figure will have a chart and a figure legend with a figure ID and an explanation of what's contained in that figure. And so when you're writing results, it's a good idea to do a figure link. And so you can say, we compared these two groups, figure one, so that people know, okay, I'm looking at this data. If I want to see it graphically, I can look at figure one and there's the data. Okay? So maybe we could write exercise increased heart rate of students from, let's just say 66 plus or minus, insert plus or minus symbol.
No. Watch this.
Alright, well in here somewhere is a plus or minus. I promise it's in there somewhere. So see if you guys can find it. So we'll say plus or minus 2.1 maybe beats per minute at rest. Okay, so now we have a result. Exercise increased heart rate of students from this at rest to this after 60 seconds of exercise. Now it's important that if you are telling me that it's increased or changed in any way, that we include some of our statistics. And so we can easily do that by just listing our p-value. So in this case it was p is less than 0.001. And then we also want to include the name of the test that we used. So we have an idea of what kind of statistical representation to look at. If you guys want to tell even more of a story with your results, you could say exercise increased the heart rate of students by 98% from this to this. Right? And then maybe you want to tie another result into that and help make your story. You could say that systolic blood pressure was also increased so let's say 120 plus or minus 11 millimeters of mercury. now we've made the link that heart rate and systolic blood pressure were both increased. And we've told a bit of a story by saying how much they've changed, not just with numbers, but with percentages.
Do you want your font size?
Pardon me?
Do you want your font size? Just
Yeah.
see. Okay.
So that would be one way that you guys could potentially write your results. And so this, by doing it this way, we're not saying blood pressure was this and increased to this. Systolic blood pressure was this and increased to this. And tidal volume increased to this. You know, it tells a bit of a story. Does that make sense, everybody? And one other thing we can add is our figure. So now we know that heart rate of students increased by 98% and went from this number to this number after 60 seconds of exercise. The p-value was less than 0.001, so we know it was a very strong effect. We did our statistics using a paired t-test, and if you want to see the data graphically, you can look at figure 1. It's pretty straightforward. Does anybody have any questions about any of that?
Where does the 66 plus or minus 2.1 and 121 plus or minus 11.1 come from?
They're just numbers that I made up for this. If I went back to Minitab and looked at my heart rate, you know, these would be the actual numbers that you guys would use. Okay? I created these numbers off the top of my head just for the sake of the example.
Pardon?
Okay, so you guys will use your real data here.
No, because I didn't know if you wanted like the systolic ones. No, we need it.
And I should actually also include that
No,
however many digits you have in your standard error is how many decimal digits you should have in your mean. So you're either gonna say 66.1 plus or minus 2.1 or 66 plus 2. Minitab reports it to 2, so you can give it 2. Any comments on it?
I think it's good. Is there any part that you wanna see him do again that maybe you didn't write down? Do you wanna see him enter data again and see how he got?
Should BP be
Graph?
converted to MAP?
What I've been saying is I would run statistics on all of them. So what you can do is do statistics on systolic and diastolic, and then calculate MAP, and do statistics on that. Because there's a chance that you might see a significant difference with systolic blood pressure and not diastolic. And when you end up calculating MAP, you lose that statistical change, right? And you guys want to write about positive data, ideally, and so in that case, you know, you might want to stick with systolic and diastolic. But if you get a significant change with MAP, I would use that. And if you don't get a significant change with any of them, I would use MAP. Okay. If you end up using systolic and diastolic, you can graph them separately, but since they're the same unit, you could actually graph them on one figure, and it does a really good job of looking at the trends between the two. And so I can show you guys how to do that. It's a little more complicated in how you set up your data, but if you understand how to set up the data, it's actually really quite simple. And I can show that to you guys. Take a couple of minutes. So if we want to end up doing systolic and diastolic on one figure together, we're still going to run our stats separately on systolic and diastolic, so they're each going to have their own column. But what we can do to graph them in a way that makes the figure quite meaningful is to put them on the same graph in groups. And so we can graph them with your before and after systolic together and your before and after diastolic together. And so what we need to do is introduce something in Minitab called a grouping variable. And so what that is essentially our independent variable. We're telling Minitab that certain data belongs to a certain group, and we're actually just gonna put all of our data into one column. So for this one, we'll use group. For this one, we'll use systolic or diastolic, and for this one, we'll have our dependent measures of blood pressure. So if you guys want, you can format these columns and change them to text. And what that does is it allows you to enter grouping variables with text. So this one might be rest, right? So we can make these all rest, and we can make these ones exercise. Okay, so now we have a grouping variable that separates rest and exercise. Okay, now we want to also group them by systolic and diastolic. So we can do that by going just ST. Okay? And then we can enter our data. So our systolic pressure at rest for person 1 was 120. Their diastolic is 8. Okay? For person 2, we'll say it was 125 over 85. For person 3, we'll say 118 over 77. 5. Okay? And so what this does is, this here is the systolic and diastolic pressure for a single person. As is this, as is this, and as is this. Whereas this is the systolic and diastolic for the first person, just for the second treatment. And so now what we can do is use these grouping variables to sort out how we develop a graph. Okay? So everybody's okay with that so far? So what we're doing is we're taking this 120, we're telling Minitab that that blood pressure belongs to somebody in the rest group, and it's a systolic pressure. This 80 belongs to somebody in the rest group, and it's their diastolic pressure. Okay? So now what we can do is make a figure. We're gonna do it in the same way we did before, using the interval plot. However, we're gonna select a different option in this case. What we wanna do is do systolic and diastolic bars as as separate bars. And so what we can do here is compare before and after exercise systolic and before and after exercise diastolic. So we select that. Our graph variables are quite simply just our dependent measure of blood pressure. And then we want to use our grouping variables to tell the graph where to place each of the bars. And so we want to select the grouping variable that's going to separate the data on the widest scale first. And so we want to separate systolic and diastolic first, so they're separate parts of the graph. And so what we'll do is we'll click on this box, and then those grouping variables become available, and we'll select systolic and diastolic first. So it's primarily going to group it that way, and then secondarily group it according to our treatment. Okay? Don't forget your data view, same as we did before. And so what we get is a graph that shows the diastolic volume between exercise and rest.
So I could put an exercise, yeah, that would be dependent.
And systolic.
We're just looking at rest right now.
Okay? And so this is a really good way to compare them, because we can say, well, what is the the blood pressure, diastolic blood pressure doing? And does it have the same trend as the systolic blood pressure? Okay. And if you guys run the statistics on these, you can put little asterisks above these to indicate where significant differences are. And we're gonna format the groups, or format the chart in the same way that we did before. Okay? With one small caveat. We have this little descriptor down here. We don't need that. Okay, because we have all of our labels here. And so what we wanna do is change those axes labels. And so the same way we did before, we're just gonna double click on what we want to change. Okay? So while we're here, we can get rid of the high bar, the high axis line. But we also want to get rid of our axis labels, which are what these are. Okay, so we're gonna get rid of these two axis labels. We wanna leave the tick labels, because that's what these indicators are. We just hit okay, so those disappear. Everybody's okay with that? But D and S don't really mean anything either, so while we're in there, let's change our labels. Okay. Let's say,
Anything we make that one worse.
and then you would just change the formatting for your graph in the same way you did before, by changing your dependent variable axis to represent what we measured and the units that they were measured in, as well as changing our error bars to one standard error of the mean as opposed to the confidence interval. So if you guys decide to run systolic and diastolic separately, this is one way that you could graphically represent it. Or you could run them individually on two separate graphs, if that's how you want to do it. Okay? If you guys do decide to do it this way and there are significant differences, in your figure legend, you want to be careful to indicate where the differences are. Because if you put a star here, and you say stars indicate where significant differences are, how do I know that you're not comparing diastolic rest to systolic exercise? So you gotta just be mindful of how you label your significant differences and how you describe them in your figure legend. So make sure that I know that you guys are comparing these two statistically and these two statistically, but we're not comparing systolic to diastolic, because really they're two different things, so we can't compare. So everybody's okay with that? So we'll be around for the next week, guys. We have writing lab again next week, so we have the computer lab booked out again. If you guys need any help with stats or graphing or anything like that, just let us know. But like you see, Minitab is fairly straightforward, it's fairly easy to use, and it makes graphing a hell of a lot easier than Excel.
No, it's not.
And it's a lot easier to make your graphs like this.
I think it would be good over the weekend just to come in and start playing with Minitab.
Use it while it's
Just
fresh.
experiment.
Most of the computers at school do have Minitab on them, including all the ones in the library. If you guys have PCs and not Macs, I can put Minitab on your computer. And if you have a Mac, I think you can download a 30-day trial for it.